today here. My name is Kudo. I'm in charge of the corporate communication division. And my name is Kudo. It's very similar to the famous design concept name of the Kodo. So please, I hope you can remember my name as well. And now we are very excited because we can unveil the all-new CX-9 in this week, Los Angeles Auto Show this week. And prior to the world premiere, we arranged this special opportunity to introduce this production and also its technology for you. And of course, the very first opportunity to drive it, I hope you can enjoy this program. And this slide is showing today's schedules. After my opening session, we'd like to explain about the overview of the production and design. After that, you can drive the new CX-9 approximately 2 hours. And after that, please back to here again. And also, please listen to another presentation relating to the more technical side. And of course, we are willing to hear your comment after your test drive, and we are willing to reflect your comment to our future production to improve our functionality. Then I'd like to introduce our presenter today. The Hitomi-san, he is Mr. Engine. And also Otsuka-san, Chief Engineer of CX-9. And also Tomita-san, Head of the Vehicle Development. And Design Director Julian Montius. And R&D Manager Dave Coleman. No? Okay. And in addition, we have many staffs from our communication and marketing team from Japan and the USA as well. And if you need some assistance, please do not hesitate to contact us. Thank you. So now I'd like to invite the Chief Engineer of the CX-9, Mr. Otsuka. Otsuka-san, please.
Thank you, Kudo-san. Good afternoon, everyone. So, and then welcome this driving event, and welcome Los Angeles. So, the original CX-9 was introduced in 2007. It had a emotion, sophisticated design, and a great driving experience. It was very different from the boxy SUVs of the time, and won North American Truck of the Year in 2008. Now, CX-9 has been reborn. Today, I'm very happy to introduce you to our new mid-size crossover SUV. All new CX-9. The new CX-9 will be a high-end model in our new generation lineup. It has our best sky-active technologies and latest Kodo design. So it will stand out with distinctive design, great performance, and class-leading fuel economy. When working on the new CX-9, we wanted to make sure the model was a match for the North American market. Global sales will be 50,000 units per year, and 80% will be sold here. So we tailored new CX-9 for this market. Of course, we also stayed true to Mazda's car-making philosophy. With this combination, we created a family car different from any other. CX-9 development team included both Japanese and US members. In early planning, US took the lead with the market analysis. With their insight, we set the target for key functions, design, and craftsmanship to meet the taste of customer here. Japan took the lead in engineering phase. Then we finalized the development back to in the United States. We worked together as one team and debated passionately to build exactly the right car for North America. Of course, customers in any country with wide open spaces will find it a match for them too. And the result, the CX-9 today is even better than I expected. I am excited to hear your impression later. Before I talk about the specifics, let me explain the concept and approach we took in development. Original CX-9 brought new value to the segment. We wanted the new CX-9 to do the same. After a lot of discussion with our US team, we decided on our product concept called Smart Indulgence. Put simply, it is a new kind of crossover SUV that enhance all aspects of your life, not only as a parent. Let me explain. Our target customer is an established family, 2+ children. When planning, we do customer analysis, but we don't use big data. We interview real people, like our target customers. We want to understand their values and real needs. In these interviews, we found these customers want to be good parents, but they are also individuals and they want to enjoy life. In other words, they want to live smart and balance their own interest with family life. Therefore, CX-9 must be a car that excites, a car that helps people enjoy life. Of course, it must be functional and practical, but in addition, it must have some X factor. You can't explain it, but it appeals directly to your emotions. We had many discussions about what that means. To make this concrete during the development process was a big challenge, but finally, we decided the most important thing is to engage people's senses. What makes a customer judge if something is good or bad? Mostly, it is unconscious. In a car, for example, how does the steering feel? What about the LVH and performance feel? How do the bottom feel? The smell and the touch of the leather? We concluded if something worked together in a holistic way, people will naturally feel this is a good car. Our challenge was to explore the mystery of people's senses and achieve a new level of holistic product execution. We believe this kind of challenge is what Mazda does well. Maybe we can do these things only because we are Mazda. Next, I will touch on 3 key features of the CX-9. First is design. Visually exciting design is the most important. Embody Coda design, the exterior flows horizontally and gives a powerful and a beautiful look with a premium feel. Yet, the cabin offers the space that a family needs. When you get in the car, you will see a truly beautiful sight. Second point is dynamic performance. It is another attribute to stimulate the senses, including hearing and seeing. The all-new CX-9 is powered by the new turbocharged Skyactiv G2.5T. The key features of the engine is low-end torque. We researched how SUV owners drive, and we found they almost never push the engine over 3,000 RPM. So, we focus on the performance in this range. The result is a linear and powerful acceleration with great response. Plus, real-world fuel economy is excellent. Key feature of our AWD system, iActive AWD, is to predict traction loss before it occurs. With this system, you can drive on any kind of road surface with confidence. Thanks to the latest Skyactiv body and Skyactiv chassis, new CX-9 has excellent driving performance that stimulates the senses. It offers solid handling, a premium ride feel, a very quiet cabin, and a pleasing engine sound. Also, new CX-9 is engineered to earn top safety rating. We achieved all these things and reduced weight by over 100 kilograms at the same time. Third point is features that meet the needs of the modern family's lifestyle. For example, active safety is essential for a family car. CX-9 provides a wide range of iActive safety features. We also focused on the HMI and Mazda Connect. Cockpit design is based on the heads-up cockpit concept, which helps the drivers concentrate on driving safely. New CX-9 is the first Mazda to adopt a color active driving display projected on the windscreen. The cabin space is carefully designed to meet the needs of a modern family. Second row seat is easy for kids to slide forward so they can access the servo. USB port and sunshade in the back make it a very comfortable place to be. These are just few things we have done to make all new CX-9 appeal to the senses. Thanks to this, I believe that we have created the most attractive and exciting three-row mid-size crossover SUV on the market. I hope that appeal to your senses and stirs your emotions. And after you drive it, I hope you agree with me. So now, Mazda USA Design Director Julia Motis is going to tell you more about the design area of the CX-9. Thank you very much, Julia.
Morning, everyone.
Good morning.
It's a pretty small group, so just to keep it things casual, like don't hesitate to cut me off and ask some questions along the design analysis. So let's start with basically the way we engage that development, interior and exterior. We've had the correlation between different design studios, but we kind of revolve around this idea of honmono, which is this journey to being authentic. Authentic to the brand, we have to be true to Mazda. And you can see that images again revolve around this idea of joy of driving, which is everything that Mazda represents. So from design, how do we kind of engineer this idea of joy of driving even from 100 yards away, Kodo expresses a quality of surfacing that's emotionally engaging you with the product. And we also had to be true to the mid-size SUV needs, meaning that the cabin had to be very comfortable, visually, but also, physically, as well as a lot of versatile seat configuration. Now, looking at the design kind of recipe, and like Kodo is basically expressing the speed through one single horizontal motion. This is a picture of an RX concept from Tokyo. So you can see clearly, even the surfacing is soft, you can see that the car is very directional. So, that kind of philosophy is brought up even to the CX-9. Like Otsuka-san said, Mazda is not performance metric. We're all about being emotional metrics. We're not the company that's going to give you the most cubic foot, interior space. We're here to bring a lot of emotion, and therefore find the perfect balance between self-indulgence and also easy parenting. So grabbing that information and taking it into design, we call this ideal and contrast between alluring and prestige. And this is kind of to give you guys an idea of, like, for us designers to look at a board of imagery that influence the alluring, which serve the self between sexy, inviting, slick, and warm, but also the family, in which prestige. If you look at the previous CX-9, like the front end was maybe a little bit submissive. This time we have to show the prestige side of the car. From 100 yards away, the car has to be very proud. In terms of the design codes, obviously we start always by proportion to really establish the power, the strength, the trapezoid stance. Then we go to surfacing, so this is really where Kodo is fully expressing itself. And on top of it, we've got detail, and this is how we're going to reach this new level of sophistication for Mazda and above our competitors. This is where we can make a true difference. Let's start with exterior, and that first picture, quite important, like that RX Vision picture. You can see that we concentrate that horizontal band. All the strength of the vehicle is being articulated through that mid band here in the center, with really high quality surfacing, sharp and lean surfaces. Now, and then we looked at even the runner, like you have always down below, very strong ergonomics, very stable, and as you go on the upper, actually you're becoming a lot more lean, a lot more athletic and lightweight. So we took that same recipe and applied it to our CX-9. So this is, again, what when you look at every car that we have today on the road, applying that Kodo surfacing. Very lean, very sharp, but then down below, everything is a lot more massive. We want it to be massive because we want it to be a lot more stable, to anchor the car with the road, to get these kind of like prestige feelings. And in terms of this idea of trapezoid stand, we look at architecture, that everything revolves around this kind of triangular kind of recipe to make sure that everything looks very stable. So when you look at the car from the front, part of the designer's tool is either you can work with hard edges, but you work also with the reflection of what the car, imagine the car going through like a blue sky with a building reflecting to it. By massaging a lot of those corners, we are able to concentrate a lot of the highlight and reflection in the trapezoid stance. So we did that from the front, but also from the rear, to make sure that the car always got this very strong, not straight, not inverted, but always trapezoid stand to look extremely strong. And you'll notice when you drive the car, even though with the camo you can see straight from the front, straight from the back, we have great stance on the road. Here again, another shot from three-quarter rear. And then the front face, extremely important. This is where the entire design is basically born. Instead of looking at the car, designing the front, the side, the rear, this is basically the skeleton. This is the spine of the car. We plug it from the front, and you can see that we basically push the boundaries of manufacturing, extruding all the signature wing all the way through the LED lamps. And actually that thematic is going to go and continue all the way through the car through the interior and back to the exterior for the tail lamp again. So we're really trying to merge, both entities. Instead of having two separate buckets, we're trying to link, all of them together. And our link is the grille. In terms of the lighting, this is just a sequence to show you, how it works. Signature lighting around the grille, the blinkers around the eyelid, and then the fog lamps down below. Same for the rear, the eyelid down there, and then the LED deck, again, to stabilize the car from the rear view. Rear lights and the braking lights. Now, in terms of the paint, we had to go back to like Mazda's essence, the way Mazda has been like milling, going through like hundreds of rotary engine, but there is like a color material palette that come out of all that, those years of research and development. And we looked at even the chipped off metal carved out of aluminum or steel, and basically came up with a new paint, a machine gray. And on this picture, you can see best represented this idea of liquid metal. The car is very reflective and really allow for all those sharp and lean surfaces to shine and showcase the car as best as possible. So in terms of the process, there's many layers applied, but one very important piece of that process is Mazda is able to control those metal flakes for them to basically lay completely flat on top of the surface in order to get that perfect kind of high quality liquid metal type of surfacing. Now in terms of refined details, designs working to integrate and disintegrate all those parts to go for the next level of corridor. But at the end, it has to be a master puzzle, how everything keys together perfectly. And engineering, craftsmanship team, and design work to make sure that all the cut line and all of those parts come together, especially the signature ring protruding all the way through the LED lamps. All of it looks really high level, and I think we pushed it to the highest level so far at Mazda. And the same for the tail lamp. The grille's going straight for the car, it's coming out, very blade-like detail here on the front, and then integrating, again, this three-dimensional treatment of the tail lamp. So this is what we talked about. The grille is basically, it's so extruded that it's going to connect exterior, interior, exterior again. Same from the rear view. You can see it just pouring there. All right, now looking at the interior, we know Mazda is pretty good at showcasing sporty interior. This was an opportunity to kind of bring it closer to like a comfortable, sophisticated home. So when you get into the car, it's very inviting to you. So this is again the best representation from the passenger seat, and you can see how we kind of structured the whole dash to basically compress the whole dash and make it more of a lightweight feel. Now from the driver's view, one important dashboard construction is that we pushed the midsection all the way to the pillar. And you can see that basically by expanding that band all the way to the door, when you sit into it, you have this, this feeling of horizontal spaciousness. Yet down below, you've got a lot more, again, massive, wide console to get, the idea of contrast between, again, the runner that we looked at earlier, between the legs and the upper body. So we apply the same philosophy for the interior. And now the directional dynamic, this is something that we work really hard with in design, is to when you get into the car, behind the wheel, you're not really sure why, but you feel connected with the car. And we do that by basically aligning a lot of the high contrast or trim that you can see on the console. Specifically from that view when you're driving, you're going to see that highly reflective trim going to connect perfectly with what you have on the wheel, and both of those on each side are going to merge into this the center gauge. If you move this a couple of degrees, you will lose that completely. And it's a design exercise to make sure, and we're playing with psychology when you sit behind the car, there's something that connects you. So this is again one trick that design use to make you feel connected with the car. There's other ones, you know, around the car, but this is the most obvious one. And then the link from the grille, as we talked earlier, the grille is going to come out, you know, straight through the hood, come back in, and all of those shapes are the result of this grille being extruded and literally just cut. So what you see is the result of that cut from the door, but also from the console. All of the design is about this horizontal movement being cut. On the next, we're talking about the confidence stand, and this is again about the console. We've raised the height of the shifter, and we emphasize the width of the console. So when you look at it, again, this idea of prestige, you've got a lot of comment on it, but again, it's about, you know, this idea of being confident and empowered by the car. Now, talking about the warm character lighting, this will be a sequence from the driver's view. When you open the door, you can see the animation between our 3 gauges. And an engine start between Mazda Connect and, of course, a new colored HUD system. And then craftsmanship. If you guys want to take a look, actually on the other room behind you, we're going to have a lot of small samples. So when you have time today, please have a look. But basically, we are going to show you, you know, how we're incorporating a lot of Japanese artisan that's blending a lot of the warm and the cool material all together into one single entity. This is just a close shot of the console, but you're going from your black flush molded to like real leather with French seam on it. Then you go to the real wood materials, then the real aluminum, and then again plastic. But all of this is concentrated in a perfect master puzzle. And again, it's another hit for Mazda to get to that craftsmanship level that we haven't accomplished so far. So each part is basically being laid down, you know, by hand. We select it, and every car will be different. You know, we're matching. We're going to select all the sheet of wood to make sure that it corresponds to the palette of the leather. But basically, every car will be unique. And also the way we work with the aluminum, going back to the Japanese craftsmanship. The aluminum will be real. It's a stamped piece aluminum that allows you to get a great contrast between the warmth of the leather and the very cool feel and aesthetic of the metal. And again, this image refers to the Japanese transition and how we handwork the aluminum. In terms of craftsmanship, the high-grade leather, the entire seat is being designed to best showcase the high-grade leather. We're spending a lot of money to get the best leather. So between the perf, the French seam, and even the sectioning of the seat, we're able to showcase that level. And then a few shots in front of the house. Great shots. You can see again what we talked about, the lower being extremely stable, and the upper being held by the grille, you know, being extruded outside, inside, outside again. It's very directional, it's very dynamic, yet it's a 7-passenger vehicle. So we call the rear and the front. Another rear. I think that's all for my part. Is Jacob here? Thank you very much.
Hi, my name is Jacob Brown. I'm with Product Communications at Mazda North American Operations. We are going to go over some housekeeping. Just first things first, we have an embargo on everything, which is photos, technical material, all of that, until until Wednesday, November 18th at 2 p.m. That's when our embargo officially lifts. So please respect the embargo. And then on top of that, drive impressions. You are going to be driving pre-production cars here in a little bit. The embargo for that is November 24th local time at midnight. Please check with your local PR representatives to find out what that means in your time zone. And then, so please just take note of the embargoes. There is one thing that is not under embargo for today, however. It's exterior photos. So if you're going to Insta-tweet anything, please just use photos of the exterior of the vehicle. The interior is covered with heavy vinyl and all sorts of camouflage. These are pre-production cars. So everybody's already seen the exterior of the, I mean, not everybody, but a good chunk of people have seen the exterior of the car already in camouflage. So we feel comfortable with that. And then hashtags for this are Mazda CX-9, Mazda CX-9, LA Auto Show, 2015 LAS, etc. If you have any questions, please contact your local PR representative. As everybody received a flash drive, which are all sitting on your tables, those have all of our photos for the press kit. Those photos, everything on that press kit falls under the first embargo for Wednesday. So after that, feel free to publish anything in there. Thank you for respecting the embargoes. This is your drive route today. So it's approximately 2 hours long, including a driver change. It's a mix of city, highway, and dynamic driving, so you get a good feel of everything. Please just, obviously, it's a lot of new technology for Mazda, a lot of new technology in general for the way it drives. So we want to give you a good mixed environment of what people will actually experience with this between highway, city, dynamic driving. As you probably saw this morning, there was a bit of wind. There's some debris in the road in some of your routes. So there will be some slight delays due to traffic, due to cleaning up debris. Then there are 3 vehicles that you will be driving, or 3 vehicles in miles per hour and 1 in kilometers per hour. There is a corresponding route book in kilometers. Then obviously lunch is served at SLS. That's no longer really applicable. Emergency contact information is in the route book in case you need to use it. So this is basically what the vehicle that you're driving looks like. Once again, feel free to take pictures of the exterior and tweet them immediately. Then I just want to note that these are not production vehicles. These are in fact hand-built. The suspension, audio, materials, and build quality are not necessarily up to production spec. Everything works though. Yes, it's camouflaged, so please don't tear off any of the vinyl. Please be respectful of the cars, both with handling them and with driving them. And then finally, all vehicles have 20-inch wheels. As you'll note in the press kit, there are some differences between which vehicles in production spec will have 18-inch wheels versus 20s. We just put 20s on these for the sake of parity. Like I said, suspension tuning is not final. Otherwise, that's it, and we'll see you we'll see you a little later this afternoon for your technical presentation. Let us know if you have any questions. Feel free to check out the materials over there, and have fun. Thank you.
Yeah, with safe redrive. Thank you very much. From now on, we'd like to give you some technical presentation from now on. And first of all, Hitomi-san will explain the consistency between the existing Skyactiv engine family and these boosted new engines. Hitomi-san, please.
Good afternoon, everyone. It's a great pleasure for me to introduce our newly developed engine, Skyactiv G 2.5T. What I am going to discuss today regards to a question as to why Mazda has developed such an engine, and I will try to explain the reason by sharing our overall strategy for technologies used for Skyactiv engine. Back in 2007, Mazda announced its vision as sustainable zoom strategy and made a commitment to provide all customers who purchase Mazda vehicle with driving pleasure as well as outstanding environmental and safety performance. In line with this vision, we made a series of sky-active engines through which we have been delivering consistent values, which are the outstanding driving dynamics and excellent real-world fuel economy at the most practical driving condition for customers. And we provide them for customers at affordable pricing around the world. It is important to provide high torque in low to mid-speed range along with quick response and linear acceleration. Ability to run on regular gasoline is another imperative as well. I would not deny the importance of what figures are shown in brochures for maximum power output, fuel economy, and marginal performance. But again, we believe the real-world performance is more important than those things for a majority of customers. We have a development policy that cuts through our entire engine series. We call this right sizing and right architecture. As a result, all the Skyactiv G engine below 2.5 liter introduced so far are naturally aspirated, as you can see. Now let me give you a quick recap of Skyactiv engine by using Skyactiv G 2 liter as an example. We have a roadmap to reach the goal of internal combustion engine efficiency. Before showing you the roadmap, I will explain our basic concept. Improving fuel efficiency means nothing other than reducing energy loss. Internal combustion engine has 4 major losses: exhaust loss, cooling loss, mechanical friction loss, and pumping loss. To reduce these 4 major losses, we have only 7 control factors listed at the far left of the chart. This chart shows a roadmap for gasoline and diesel engine to reach the goal by controlling these 7 factors. We are actually advancing the development as per this roadmap. The Skyactiv gasoline and diesel engines, which were already introduced into market, are the first step. We are planning to reach the goal with 2 more steps. The most remarkable point of Skyactiv gasoline is the world's highest compression ratio. It's 14. The largest roadblock in increasing the compression ratio is knocking, induced by high compression ratio. We made mainly 2 technological breakthroughs to overcome this issue. First one is quick combustion, which is made possible by the optimization of fuel spray characteristics and piston cavity shape unique to Skyactiv G. The second breakthrough is the use of 4-to-1 exhaust system. This system contributes to reduce the temperature of the air and fuel mixture. The picture at the top is a conventional type called 4-1 exhaust system. The structure is rather compact, but the amount of residual gas that stays inside the combustion chamber is large, which causes knocking. The picture in the bottom is 4-to-1 exhaust system adopted for Skyactiv G. The structure enables to hold down the interference of exhaust pressure propagated from following cylinder port to avoid exhaust backflow into the cylinder. And not only that, it offers a scavenging effect, which effectively discharges the hot burnt gas from the cylinder. This concept is functionally embraced by Skyactiv G 2.5T. This slide indicates torque improvement, marking especially huge uplift at low to mid-speed range. This slide here shows the improvement in specific fuel consumption. The level of its fuel efficiency is almost the same as that of our previous generation diesel engine. According to the US Environmental Protection Agency's light-duty fuel economy report issued in 2014, Mazda was the most fuel efficient auto manufacturer for the fleet-wide fuel economy for the second consecutive year, as it did for the previous year. With that in mind, let me change gear to discuss Skyactiv G 2.5T. Skyactiv G 2.5T is a very fast turbocharged engine for Skyactiv G engine series. Do you have any idea as to when we decided to replace the current 3.7 liter V6 with 2.5 liter i4 turbo? The answer is when we developed the plan for the entire Skyactiv G engine series in the first place. It is Mazda's strategy to plan our product by bundling them together, which necessitated us to also bundle the plans for all the engines as well. In other words, the displacement and the structure of this new engine was pretty much baked into our plans as far back as 2007, which was when the development work for Skyactiv G series was initiated. Please allow me to repeat the same point. It is our philosophy to provide consistent values of Skyactiv engines, as shown here, with the right displacement fitting to its vehicle weight and by the simplest possible engine structure. This slide is a brief summary of what we did to justify boosted downsizing engine as a truly meaningful engine. Number one, quick response at acceleration and adequate low-speed torque in the same level as larger displacement naturally aspirated engine. Number two, boosted downsizing engine can easily get good fuel economy in legal mode thanks to its lower friction and pumping loss. But we must deliver good fuel economy rather in real-world driving. In order to realize it, we have to improve fuel economy at high load and high engine speed, a better level than a larger displacement naturally aspirated engine. As far as it is a boosted engine, it is forced to reduce the compression ratio compared to naturally aspirated engine, which is a drawback we must overcome. Number three, with regard to the cost, focus on changeable parts in the architecture to offset the cost of turbocharger and intercooler. The key technology to solve these three issues are dynamic pressure turbine, cooled EGR, and shifting to inline 4 from V6. Let's take a closer look at these points. For boosted engine, it is inevitable to reduce compression ratio compared to naturally aspirated engine, as I have already mentioned. This means boosted engine shows poor efficiency at mid and high load area. If you compare turbocharged engine and non-turbo engine of the same architecture, the turbo engine is for sure more costly due to the turbocharger and intercooler and various reinforcement installation. Even our Skyactiv technology doesn't allow us to do away with things like adopting direct injection, intake and exhaust variable valve timing system, which increase the cost to a certain extent. Given this fact, changing the architecture to inline 4-cylinder instead of large displacement V6 is actually the most effective way to counteract the boosted engine's handicap on fuel economy and cost. Let me touch upon part of our study on that. This slide shows the difference in engine's mechanical friction between the cases of using V6 and I4. Although downsized from 3.7 liter to 2.5 liter in the same way, switching to I4 from V6 actually resulted in over 50% bigger reduction of mechanical friction than the case of sticking to from V6 to V6 downsizing or from I4 to I4 downsizing. This played as a major factor to overcome the drawback of lowering the compression ratio for adopting boosted downsizing. Next, I am going to explain how this makes sense in terms of cost. Suppose we are going to make a Skyactiv V6 engine compared with inline 4-cylinder engine. We would have to use 1.5 times more number of cylinders, pistons, cranks, connecting rods, ignition coils, and even fuel injectors. Furthermore, we would need to double the number of cylinder heads along with the expensive electric air intake variable valve timing system mounted on cylinder heads, exhaust hydraulic variable valve time system, camshafts, exhaust pipes, and high pressure fuel rails. On the other hand, all we need for the case of making I4 turbocharged engine is to use Skyactiv 2.5 liter as the base engine and add turbocharger and intercooler to that. These features also contribute to engine weight reduction as well. So far, I have walked you through the reason why we have chosen inline 4 to construct the new engine. I'll be asking Hasan later to give you further details, so let me focus on the conclusion. As for low speed torque, combining the displacement of relatively larger displacement 2.5 liter with dynamic pressure turbine gained equivalent or higher torque compared to naturally aspirated V6 engine. Next is about the acceleration response. From the early phase after stepping on the gas pedal, it shows most steep rise in acceleration compared to competitors' turbocharged engines. Another issue of turbocharged engine is the deterioration in real-world fuel economy. There is a fact that the compression ratio for current turbocharged engine is a little stretched from the standpoint of knocking. In order to avoid deterioration of fuel economy in the right road range, this leads to a larger retard of the ignition timing from mid to high load range to avoid knocking, which causes a significant deterioration in fuel efficiency at high load. In comparison with conventional V6 engine and inline 4 turbocharged engine, our new engine has attained significantly better fuel economy thanks to deploying dynamic pressure turbine system and cooled EGR. Dynamic pressure turbine system has a function to scavenge hot residual gas at low speed area. In the same manner as 4-to-1 exhaust system in Skyactiv G naturally aspirated engine. And cooled EGR system delivers anti-knocking function and lowering exhaust gas temperature function to better fuel economy at high engine speed and high load area. This slide shows the summary of key features of Skyactiv G 2.5T. For further details on performance and technology content, Dave will take you through after this. So please continue to enjoy the remaining session. Thank you very much for your kind attention. Welcome, please.
Thank you very much. All right, hope you guys drive went well. You got to enjoy lots of stop and go traffic. I want to talk a little bit more details about how this engine works and how we sort of came to this this solution. We have a sort of a general strategy at Mazda of really focusing on the customer experience and how the car will behave in the real world, much more than looking at sort of catalog targets and specs and that kind of thing. We're more focused on sort of the whole experience. In this car, that focus really came to a couple places where we actually were at direct conflict, where if we wanted to make a better spec, we would make a worse car. And so we had to actually consciously make that call to make the better car, but with a worse spec. And I've sort of explained how some of that works. Our big high-level targets, first of all, we wanted to have the best fuel economy of any car in the segment. The fuel economy of a bigger car like this has a bigger impact on your cost of ownership than it does on a smaller car. If you start out with an economy car and you make a 10% better fuel economy, you weren't using that much fuel in the first place, so you don't save that much. The thirstier the car starts out, the more benefit you get. We focus a lot on the linearity and directness of the throttle response and how faithfully the car responds to your inputs in very focusing on really sort of small, subtle areas rather than what's it do at full throttle at the top of an engine tram. And then finally, the steering and handling really focus on making the car agile and precise in everyday driving in a way that you can notice even in a parking lot, let alone when you get out and drive it really hard. So starting off with the fuel economy. Fuel economy figures aren't official yet, so I had to take the numbers off these charts, and they're also different figures in every country because everyone has different tests. But these charts are to scale if you want to compare where we are with the rest of the segment. The main thing to notice is that each one of these highway and city fuel economy charts has two axes. There's the official rated number on the bottom, but then there's a sort of a real world axis. We have several different real world driving routes that we use. One of them is a match for Consumer Reports drive route, so that we can test the car and then we can check it against cars they've tested that we haven't, and we can make sure they line up. So these all came published from there, but you can see we really, because the previous CX-9 was a rather old design, we've been trailing the field on fuel economy. We wanted to not just catch up, a leapfrog ahead. So we're looking at about a 20% improvement in fuel economy versus the old engine. In terms of sort of how we set real-world drivability targets for this engine and how that got us to the solution that you drove today, I want to look at just sort of one example of how we do a real-world performance target. Instead of looking at wide open throttle 0 to 60, which honestly most people picking up their kids from school in a three-door SUV don't do that very often. But they do drive down the freeway, get stuck behind somebody slow, change lanes, and go around them. And that's a real simple place where you're just rolling into the throttle, got in your head an image for how hard you want to accelerate, and you just keep pushing until you get what you want. And we can map that process out on this chart, where we look at the vehicle speed and the force of acceleration that the car is producing. And this bottom line down here is just it's what we call the road load line. This is how much force it takes to just keep pushing the car along at a constant speed. So the faster you go, the more effort it takes to push that car at a constant speed. So that's our starting point. As you roll into the throttle, say in your head mentally you're looking for about this much acceleration. You quickly, this is the amount of torque that the car can, the amount of force it can generate in 6th gear. So you very quickly saturate this, and the car has to downshift, drops to 5th gear. This is how much it can do in 5th gear. It still saturates this, you're still going. And then finally it'll drop to 4th and it can give you what you want. And what happens in the real world as you're driving a car like this, each one of those downshifts takes some time. And this whole time you just keep pushing farther and farther into the throttle trying to get what you want. When it finally downshifts to 4th, you've actually put more throttle than you needed and you overshoot and you kind of have to back off and you go through this process. And we're so used to this response from any car with an automatic transmission. This is what we consider normal. But we really want to get away from that. We want a really direct response. So what we wanted was a sixth gear that could deliver this kind of torque response without having to downshift. You'll notice my road load line moved down because the new car is more efficient, more aerodynamic, and has less drag in the first place. But if we could deliver all of that acceleration in sixth gear, you have a really direct response. You're not overshooting. You're not chasing the engine around. So that's where our target starts from. And if you take this and then back out the gear ratios and the weight of the car and everything and what's physically possible in an internal combustion engine, you end up with a torque curve that looks like this, which sitting there by itself doesn't mean anything. So here is the torque curve compared to the old CX-9 or 3.7 V6. And you can see we have a completely different strategy here. Vastly more torque at low RPM where the engine is already operating when you're cruising along. And to get that, we had to sacrifice this high RPM performance. This is where we're having to sort of compromise real world versus the catalog. And so this is during the development, this is what we had to worry about is, are we okay giving away this high RPM torque to gain this low RPM torque? It seemed like a good idea. The only really way to know is to drive the car. And since we didn't have the car yet, we actually built a mechanical prototype where we took a CX-5 European spec diesel, and we retuned the diesel engine to make exactly this torque curve. The torque curve of the diesel is close enough to that. It's not that hard for us to do that. And then we put a bunch of lead weights in the car to get them up to the weight of what the CX-9 would be. And we went to, there's a couple of schools near our office where if you go there at 3 o'clock in the afternoon when people are picking up their kids, 80% of the cars on the road are premium 3-row SUVs. And so you can just go in, tuck behind these people and match their speed exactly, and you can have a really good idea of how these people are going to be driving these cars in the real world. And we plotted that out on this torque curve. We plotted out, the RPM and load points that they were hitting and what percentage of time they were in each one. This is what we found out. They never use this high RPM. If they have that much torque available, they never use the high RPM. So we are able to deliver everything they need with this torque curve. So that gave us sort of the confidence to move ahead with that. Now, how we actually pulled that off is another trick, because that nobody has that torque curve, partially because it's incredibly hard to do. Getting that much torque at that low RPM out of a turbocharged engine is tricky. The way a turbo works, you're taking the exhaust gas, spinning a turbine, which spins a compressor, which pumps more air into the engine, which then makes more exhaust energy and spins it, and this cycle. Well, getting that cycle going takes some time. That's what turbo lag comes from. And especially at very low RPM, you have very little exhaust energy to drive that with. So we needed to come up with a way to get that turbo lit up really quickly at low RPM, and we had to keep the engine very efficient. That's where this dynamic pressure turbo system kind of uses two separate technologies to make this happen. The first is this flow control valve that we use at low RPM. You can see the exhaust port here, from the exhaust valve to the turbo, there's two passages, a larger one and a smaller one. And at low RPM, below about 1600 RPM, we close off the high RPM port and we force everything through this smaller passage. It's a pretty simple concept. It's just like what happens when you put your thumb over a hose and suddenly you had very little energy from that water just sort of dribbling out, and now you can boost its speed and shoot it out across the street, right? This concept has been used in a lot of other turbo systems. It's usually called a variable nozzle turbo or something like that. A lot of diesel engines use it. 911 turbos use it. We used to use it in the RX-7 Turbo 2 about 20 years ago. This is using the concept in a different way. All of those systems will take all of the exhaust ports, get them together to merge at the turbo, and then pinch them off and shoot them at the turbine wheel. We wanted to keep the exhaust ports separate for the breathing of the engine. I'll explain that in a second. But because of that, we have a fundamentally different exhaust flow. If you merge all the cylinders together, you have a relatively continuous exhaust flow. If you look at just one cylinder, you have a pulse of exhaust and then a big delay while it gets the next cycle going, and then another pulse of exhaust. And this pulsed flow behaves differently. So by pinching off the flow earlier and having this whole column of exhaust moving at higher velocity, that whole column has more inertia. So when the end of the exhaust stroke comes along, the inertia carries it through and carries more energy through to the turbo. So that makes it actually kind of a fundamentally different usage of this technology than has been done before. The other tricky thing we did, Hitomi-san was showing you the 4-into-2-into-1 exhaust manifold of our naturally aspirated engines, right? And we used that to keep the exhaust pulses from interfering with each other. We don't have that kind of room in a turbo engine. We can't put a turbo at the end of that long exhaust manifold because the exhaust won't have enough energy by the time it gets to the turbo. We have to do all of that pulse separation in about this much space. So we have to use a completely different concept for how to keep the pulses from interfering with each other, and how to get the exhaust out of at the end of each exhaust stroke. And we use what's called the ejector effect, and this is the same thing that happens in an airbrush. Airbrush mixes air and paint together using the ejector effect. It has this straw down into the paint, and you just blow air across it. And blowing air across it creates a suction and sucks the paint up into the flow. So we figured if we could position the exhaust ports just right, we could use that same effect to draw the exhaust out at the end of each exhaust stroke. Now, the reason this works is if you look at the exhaust energy in the exhaust port, it's not constant over the whole exhaust stroke. It's really energetic at the very beginning and really fast, and then it kind of peters out at the end. So when you first open the exhaust valve, there was just a big explosion in the combustion chamber, and as soon as you crack that valve open, all this energy comes rushing out. So you have this huge pulse at the beginning. That dissipates, and then the rest of the exhaust stroke, you're just kind of shoving the rest of the gas out. And this is why it's hard for that last bit of exhaust to get out, and it's so easy to end up with leftover exhaust in there. So by arranging the cylinders in this 4-into-3 pattern, because of the firing order of a four-cylinder engine, 1, 3, 4, 2, you notice 1, 3, 4, 2, it always goes from an outside cylinder to an inside cylinder to an outside cylinder to an inside cylinder. So we never have two adjacent things going on in this same port. It always goes out to in. And we always have this energetic beginning of an exhaust stroke meeting right next to the lazy end of the previous exhaust stroke. So basically the air and the paint always meet next to each other in that merge collector. They're always side by side. If they were on opposite ends of that, if we had one over here and one over here, it wouldn't do any good. There wouldn't be enough of an effect to draw on the white cylinder there. But that 4-into-3 on a four-cylinder happens to merge everything very efficiently to use that effect. By using this effect and getting all of the exhaust out of each cylinder, we're then able to resist knock more effectively. We're able to run a higher compression ratio and get a more efficient engine. Now, the bigger tool that we use to really get the real-world fuel efficiency is this cool DGR. And you have to look at how an engine without cool DGR works to understand what we're doing here. Most piston engines have the same sort of dirty secret, that they're very efficient at light load, and they get a lot less efficient when you really get on them. And the reason for that is the higher the load is, the hotter the combustion is, and you'll reach a certain temperature where you'll start to damage the engine parts. And so you have to sort of put a cap on the combustion temperatures. And the way you control the combustion temperature, the easiest way to do it is to throw more fuel at it. If you throw more fuel than can actually be burned in that cylinder, that extra fuel actually slows down the combustion a little bit, and the evaporation of that extra fuel sucks some heat out of it and it lowers the temperature. Of course, it's a waste of fuel because you don't get any energy out of it. But it's pretty simple to do, so everybody ends up doing it. If you look at the CX-7, for example, our old 2.3 turbo engine on our previous generation engine family, this was the torque curve the engine could make at full throttle. But this is the amount of torque it could make before we got into that enrichment strategy to protect it against getting too hot. And so this is why you get really good fuel economy on the sort of fuel economy test cycle where you drive very gently. But when you drive more aggressively, it gets a lot worse. That's not unique to turbo engines. Naturally aspirated engine, this is the V6 again from the old CX-9. At lower RPM, it wasn't that big of a problem, but as these hot pulses get closer and closer together at higher speed, we can't reject the heat quickly enough, and we have to cool things down to prevent damage. So all this area, we're running this extra enrichment. So to get real-world fuel economy, we want to stay away from this enrichment as much as possible. So our target with this new engine is to stay away from enrichment in this whole area, which is basically everywhere that we're driving in the real world. And the technique we use is this cool DGR. So instead of throwing extra fuel into the cylinder to cool it, we're taking some exhaust gas, running it back around through a cooler and back into the intake. And the reason the exhaust gas helps actually cool the combustion is because we've already burned all the oxygen out of that gas. So the oxygen density is now lower, and that slows down the combustion and makes it cooler. Obviously, we put a lot of effort into that with that manifold to get the exhaust out of the cylinder. Now we're just running around and putting it back in. But the difference is we were getting it out before because it was hot. If we run it out and through a cooler first before we throw it back in, then we can take advantage of that. Obviously, displacing some of the oxygen and reduces the amount of power you can make. So this system sort of reduces the torque output of the engine, but it improves the knock resistance so much that we can then turn up and run more boost and pump more air into the engine and overcome the torque that we lost by displacing oxygen, by just shoving more oxygen in there. And you end up actually in a better place. A cooled EGR system is not a unique technology to this engine. It's used in a lot of diesel engines. It's used in a lot of large trucks. But it's very unusual to see it in a gasoline application like this. And the reason for that is you can hit the label fuel economy targets without this system. This doesn't affect the fuel economy that we advertise at all. It only affects the fuel economy you get in the real world. So it's only because we focus on the real world customers more than the catalog that we actually went to the effort to do this. But we think ultimately it's going to pay off in the way people enjoy their cars. Speaking of catalogs, we do have the ability to make a little bit more power if you run premium fuel. We tuned this whole engine anticipating a regular fuel, but there was an opportunity to make a little bit more power at high RPM with premium. Regular fuel, this is the torque curve we've been looking at the rest of the presentation. We can do that on premium. Typically, if there's an engine that makes more power on premium than on regular, they'll just give you the premium output and don't say anything about regular, they'll just say premium recommended. If you talk to customers about what that means to them, they have no idea why it's recommended or if it's safe to run regular fuel. And a lot of people end up running premium who don't actually drive in a way that it's going to benefit them at all. So we thought it'd be a lot easier and more understandable for our customers if we just explained what's actually going on. So we're actually going to have two horsepower ratings. It's going to have an 87 or regular fuel rating and a premium fuel rating of 230 horsepower and 253 horsepower, and only one torque rating because the torque doesn't change, and only one fuel economy rating because you don't use that high RPM area at all in kind of fuel economy driving. Change subject real quick to the all-wheel drive system. We use our new iActive all-wheel drive in this car. This is a similar system that's in the CX-5 and the CX-3. Of course, it's scaled up. None of the parts are shared between any of these three cars, but the logic is the same. The mechanical system is pretty straightforward and pretty similar to everybody else's all-wheel drive. You have front-wheel drive and you have an axle that takes power back to the rear diff. And then you have a clutch between that drive shaft and the rear diff. And if you have that clutch open, it's front-wheel drive. If you lock the clutch, it's four-wheel drive. And if you let it slip a little bit, it's somewhere in between. The magic is in the controlling of that clutch and knowing when you should engage it and how much. Traditional all-wheel drive systems will wait until the front tires slip a little bit and then engage the four-wheel drive. This lets you get the maximum fuel economy by not wasting any torque, putting load on those gears in the back. But it makes the car lose control for a second and then regain control. We want the driving experience to be completely seamless. The car to have to be very consistent on all surfaces, on wet or snowy. So we don't want that moment of lost control. So what we wanted to do is get a system that's intelligent enough to anticipate when there's going to be a need for more traction and engage the system then. And that requires looking in a lot of detail at what the conditions are outside the car. It turns out that we have so many sensors in the car already for other systems that if we just use those intelligently, we don't have to add any other sensors to get this information into the all-wheel drive system. So, for example, we know if it's cold enough for there to be ice or snow because we have an outside temperature gauge on the dash already. So we just feed that data into the system. We know if it's raining or not because if it's raining, you turn on the windshield wipers. So we feed the wiper data into the system. We can actually measure the surface grip directly by looking at the steering system. So if you notice, if you're driving around a corner and you hit a sandy spot or a puddle or something, the steering will get light for a second. Well, we have that data in extremely fine detail through the electric power steering. There is a torque sensor in there. It knows the steering angle, it knows the cornering G, and it knows what relationship those things should have. So when the steering gets a little bit light as the grip is reduced, we see that, and we can correlate that directly with a coefficient of friction on the surface. If you're not going around a corner, we can still look at the individual wheel speeds and see if we're running in front-wheel drive and the front tires are starting to go a little bit faster than the rears. That means the grip is reduced, and we can again measure the surface friction that way. We can also tell if the cars, if we're sitting still and we're about to pull away from a start, we know if we're on an incline, because we have a G sensor in the car that we use for the stability control system. So we feed that into it as well. And so if we take all that information to build a picture of what's going on in the outside world, and then just look at the driver's inputs, understand what they're intending to do, we can get a system that works completely seamlessly, never slips that front tire before engaging the rear, and unfortunately works so incredibly well that nobody even notices the thing's there. So it makes it very hard for people to appreciate sometimes how good this all-wheel drive system is, because when it works perfectly, it's completely invisible. Especially in weather like today, where it's never going to slip anyway. Another area we worked really hard on this car is NVH. Mazda has traditionally been weak on NVH. We're really good on driving dynamics, but the cars are kind of loud. This reason for that is because there's a direct conflict between NVH and steering and handling usually. The tires that make a car very quiet tend to be really squishy and unresponsive. A lot of the sound deadening materials are really heavy, and we're always going for a really lightweight target on our cars. So this has sort of been our problem for a long time. For the CX-9, we decided we're going to address this head on, and again, leapfrog from the back of the pack all the way to best in class on NVH. We look at NVH on two different axes. One is road noise, low frequency noise, which is simply just the sound pressure level of the sound coming in from the tires. And the high frequency noise that typically comes from wind noise, we put on a different scale. It's called an articulation index. And that's a set of frequencies that people use in speech. So if we address specifically those frequencies that people are using to talk to each other, we can make it easier to have a conversation in the car, easier to listen to music, for example. And so that's where we focus our effort instead of on other areas. So I'm not an NVH engineer. I can't give you a whole lot of details, but just sort of the high level. The way we approach the wind noise is a lot of fine details in door seals and window seals. There's a couple of extra seals that we're using where we weren't before, or moving the seal a little millimeter closer to the surface can make a big difference in wind noise. Sort of the only really big hammer that we used here is the acoustic glass. There's a kind of glass you can use that's a sound absorbing layer in between two layers of glass. We use that in the windshield in several of our cars. We're using it in the windshield here. This is the first time we're also using that acoustic glass in the front side windows, because that knocks out all of the wind coming from the side mirrors that's normally transmitted right through the glass. That made a big difference. The road noise is the bigger challenge for us, because again, there's that compromise where we can make the road noise really quiet by putting really soft, squishy tires on the car, but then we don't have the steering response that we want. So instead, we looked at where the sound is coming up through the floor, and we sort of took a multi-layered approach to blocking that sound. The first layer is below, on the outside of the car, we have an aerodynamic under tray. It's just a plastic tray that hangs a couple inches below the bottom of the floor. That tray has a soft felt-like material on it that absorbs certain frequencies before they even get into the interior. Next is the sheet metal itself. We increased the thickness of that sheet metal, which blocks a lot of sound. There are a couple of areas that we needed to reinforce for offset crash performance, and there are different ways that you can achieve that crash performance. We chose a thicker floor pan because that also gives us better NVH for the most of the time when you're not crashing into things. And then finally, the big thing we did is put a lot of sound deadening in underneath the carpet. For comparison, if you look at a CX-5, there's 4 kilograms of sound deadening underneath the carpet. Only a slightly larger carpet in this car is 24 kilograms. It's a huge amount of weight that we're willing to put into the car. For a Mazda engineer, it's very hard to put that much weight into a car, but we had saved so much weight in this car in the first place with a stronger, more efficient structure, with a lighter engine, with a lighter all-wheel drive system, that we were able to put this extra weight into the sound deadening and come out with a much more enjoyable package. And finally, I want to talk a little bit about our steering and handling tuning and the philosophy we use for tuning the way the car drives. we've talked about this phrase "Jinbai Itai" before. Usually, when we're doing an MX-5 introduction, it was a phrase we first started using in development of the first MX-5 25 years ago. The term is very Japanese, and I think it's one of those things that if you say it to a Japanese person, they immediately understand what you're talking about. It takes a little bit more explanation for us. So there's an ancient Japanese horse archery where the guy will be riding on a horse and shooting at a target as he rides past at full gallop. And this takes an incredible sort of coordination relationship between the horse and the rider for him to be able to stand up there with hands off on a galloping horse and be able to know exactly when each stride is going to be and how the horse is going to be moving, so we can release it at exactly the right time. It takes a real connection. This sort of Jinbai Tai gets translated as oneness between horse and rider, or oneness between the driver and the car, and that's sort of the philosophy we use in tuning the steering and handling. And that sort of kind of just directs everybody toward where the priorities are, rather than trying to get the best cornering numbers or something. It's more focusing on the details and on this connection that you feel with the car, and making sure that it responds to everything you want it to do very precisely and very immediately. And that lets us really focus on very minute details. For this generation of cars, this whole Skyactiv generation, we've tried to kind of focus on a more logical approach to how we do this tuning. The problem with trying to make a car move intuitively and respond intuitively is everybody has a little bit of a different sense of what intuitive means and what they're expecting. And so we started studying human anatomy more closely to get a more universal sense of what is intuitive. And some examples of what we learned from that. If you look at a person that's walking, if you're just walking along, as I walk back and forth here, from my standpoint, I feel like I'm just moving horizontally in a completely smooth way. But if you look very closely, my eyes are actually kind of bouncing up and down a little bit. I've got this elaborate suspension system with my legs doing all this stuff, and it's not perfect, and there's a slight sort of sine wave movement at my head. And it turns out this is what people think of as normal and flat. And in the past, a lot of times we've spent a lot of effort into making the car really stiff to give it a really kind of secure, planted feel. And it turns out that as long as the damping controls the large motions well, and the front and the rear of the car move together, this sort of small, gentle undulation, it gets completely edited out by your brain. And you can actually make the car a little bit more supple, a little bit more soft, and still have it feel completely secure. We also did a lot of effort looking at how people sense the different forces that happen as a car goes through a corner. There is a roll motion, there's a yaw motion as you turn like this, there's a cornering G-force that you've got to brace your body against. And if we look at how people sense those things, and realize that people are having to subconsciously brace their body against these forces, and if we deliver them in the right order and in the right way, it's a lot easier for people to brace themselves. And nobody really thinks about, oh, I'm bracing myself in the car in normal driving, but it's a subconscious thing that goes on that makes you feel more comfortable. So, for example, we figured out that the first signal that you're going into a corner is if you're looking out and you see the car start to roll a little bit, that sort of triggers your responses kind of tense up for that corner. So we try to make sure that the cars have a little bit of a diagonal roll initially that you can see. We design the car so that you can see the hood. For example, a lot of cars, the view stops at the dashboard. You can see the hood, you can see it start to move. And that gives this subtle input that lets you brace for the corner. We also make sure that the timing between that motion and the beginning of the yaw and the beginning of the G is very consistent in every corner. There's no friction that's kind of binding things up and then breaking loose. It takes a lot of sort of subtle details to make the car behave in this way, but once everybody sort of understands that's what the target is, we're able to do it. And finally, from the driver's standpoint, the driver's touching the steering wheel the whole time through the whole corner. And there's a lot of information coming through that steering wheel. So we put a lot more effort into making steering feedback that is honest and consistent. So that the amount of force that you're feeling through the steering wheel directly corresponds to the amount of cornering force you're getting. If you drove an old CX-9 and a new CX-9 back to back, you're feeling a 10-year progression in our tuning philosophy. So it's a really dramatic difference, especially in terms of steering feel. The old CX-9 would tend to have a lot of buildup right around center, so it would sort of self-center really well. But if you got deeper into a corner, it would go flat, and it almost felt like it was falling into the corner. It made the car feel very agile, but you couldn't control it very precisely. And as a result, you end up making these kind of sawing motions at the wheel, and your passengers are getting thrown around because they don't know what to expect. So the better the feedback is and the more precise the car is in its response, the less corrections you have to make, the better driver you become, the better ride your passengers have. Even if they've had their eyes closed and didn't see that little initial roll, you're driving better, and so you're putting a smoother force on them. So all this sort of comes together to make a more comfortable experience for everybody in the car. And you know, we tend to think of, we still do have a lot of high G antics in our steering and handling targets. We still make sure the cars corner well at high speed and are really balanced and neutral and have a little bit of lift, throttle, oversteer, and all that stuff. But taking this philosophy lets that effort pay off in the most mundane driving. Just pulling out of a parking lot, the car behaves very precisely and very predictably, and pays off for everybody in the car. So that's all the rambling I've got for you. So I guess we're going to bring everybody back up here and answer some questions if you have any. We're going to start translating back and forth between English and Japanese. I'm going to start speaking Japanese, and they're going to translate into Russian, I think is the plan.
All right. Few points to note really quickly. Just remember the embargoes. Please keep everything embargoed until the respective dates. If you are not entirely sure because you're from a different time zone, please consult with your local PR reps. And then otherwise, we have these translation devices. We highly recommend you use them because there are some presenters who speak Japanese a lot better than they speak English and vice versa. So, and then lastly, all of the presentations that you see here, you will be getting them by about Wednesday-ish. So we will PDF them and send them out. So if you missed anything, we should have that over to you shortly. Otherwise, let's please bring up our presenters and take it away. Do we have the microphones? Cool. Hey, Yoshi-san.
Our translators need us to speak into microphones, so that's why this strange little formality in this small room.
Here.